All right, so here is the continuation of section 9.1 dealing with ellipses, and we're talking about how to graph an ellipse. We've already looked at the notes for the graphing of an ellipse that has an origin or has a center at the origin. Now we're going to talk about what's going to happen when we have translations, where we have them moved from having a center at the origin. Well, you're going to find that it's very, very similar to what you did with a circle. If you remember, when you were in geometry, you should have learned that the equation for a circle is x minus h quantity squared plus y minus k quantity squared equals r squared. Well, this means that hk is the center and r is the radius. Now, because we've got an ellipse, we're of course not going to have a radius for this thing, but we are going to have it in a certain way where we're going to be able to know which way is the long axis, which way is the short axis. Well, we've already looked at that, and that has to do with which one is the larger of the two numbers squared on the bottom. That's going to tell you. Now, all that you're going to do with this is you're going to shift h left or right and k up or down. So all you do is when you pull it out of here, you're going to change the sign. So if this had been x minus 3, it's actually going to have a center at 3, at x equals 3. So if we had x minus 3, we have a center at 3, and let's say we've got y plus 4, this would have a center at positive 3, negative 4. We change the signs when we pull it out. So if we had x minus 3 squared over, let's say 5 squared, plus y plus 4 squared over 9 squared, we would have an ellipse that had its center at 3, negative 4. And then once we did that center, remember all the stuff that we did in the graphing previously, you figure out which of course is your major axis, and you go out that a distance. So the distance A in both directions. And then that's where you're going to put your vertices, your major vertices. And then perpendicular to that, the other way, you're going to go out B units. And that's where you're going to put your minor vertices. And then that's going to give you the ability to sketch this thing. And then you can go along the major axis C units in both directions when you solve for C, remembering that C squared equals A squared minus B squared. You can plug in the A and the B and solve for C. And then you can go out C and plot your foci. And that's it. That's all there is to it. So the big thing is being able to identify what your center is, and then you're going to build that ellipse from there. All right, so this is in your book, and there's lots and lots and lots of information here, and it tells you about it and everything, but everything's going to stay exactly the same. It says the major axis in this case is exactly the same as it was before. If it's a horizontal major axis, that means that the a squared, the larger of the two numbers on the bottom, is under the x. If it's a vertical major axis, that means the a squared, the larger of the two numbers on the bottom, is under the y. The only thing that's really changing here, and you can look here and here and here, it's that they have equations for actually being able to find what the vertices are and all that stuff. Guys, don't worry about trying to memorize those functions or those equations, because once you know h, k, then you know that you're going to go subtract a and add a to h if it's a major axis that's horizontal, and you're going to add a and subtract a from k if it's a major axis that's vertical. And everything else is going to go along the same way. Just understand you're not going, you're going 3 and 3 in other directions, but you're not starting at 0 again. So you actually have to do some addition and subtraction to find out what those actual coordinates are. And remember, you're going to have to list those vertices. And I don't want to see h minus a, I want to see whatever that number ends up being. Alright, so let's do one of these, and then you'll kind of have an understanding of what's going on. And guys, all this should be in your notes. I know this is kind of weird and we haven't done this, but all this should be in your notes. You should continue your 9-1 notes by following along with the video and writing all this stuff down. Now, you don't have to write all that entire big table that we just left, but you got to write the key points and all those things that you need to know for being able to do these. The H and K information and stuff like that from that first slide, definitely, but you don't have to copy down that second slide with a big table. Now, you definitely want to work out this example here with me, and then you may even want to try that other one before you actually look, the next one before you look at the solution. And I'll give you a chance to pause it if you want to try it. All right, so here is what we've got. We've got x minus 1 squared over 4 plus y plus 2 quantity squared over 9 equals 1. Where are the foci located? So they want you to graph it and then identify the foci. Now we're going to identify all the key points, and starting off we're going to identify what the center is. Well, the center is going to be 1, negative 2. So here all I did was I took these out and changed the sign. That's all you're doing. So 1, negative 2, and I'm going to make a point there because that's my center. I'm going to build everything I have as far as this ellipse off of that point right there. Now, next thing you want to identify, is it a horizontal major axis or a vertical major axis? Well, just look at the numbers on the bottom. Which one's the larger? Well, 9 is. So that means it's under the Y. So this is a vertical major axis. And we can go ahead and list this and say that A is 3 and B is 2. We could even go ahead and find out what C is. 9 minus 4 equals 5 is C squared. So C equals the square root of 5. All right, and then from there, remember, all we need for our major vertices, since it's a vertical major axis, we're going to add and subtract A to Y. So from my center here, so if I'm at 1, negative 2, and I add 3, 1, 2, 3, I'm going to have a vertex right there. Well, identify that point. It's 1, 1. All right, and then from there, I need to go down 3. 1, 2, 3. Plot a point there. That is 1, negative 5. Now, if you don't want to do that by graphing, just remember, since it's vertical, your y changes, so add 3 to this and subtract 3 from that. That's all you're doing. That's where these numbers came from. All right, and then for your minor vertices, you're going to move from the center left and right B units. So I'm going to add 2. That's going to give me 3, negative 2. And I'm going to subtract 2 from 1. And that's going to give me negative 1, negative 2. So I have 3, 1, 2, 3, negative 2 right there. And I have negative 1, negative 2 right there. Now at that point, I can kind of get an idea of what my ellipse is going to look like. Something like that. Doesn't have to be perfect. Now we have not identified our foci yet. Guess what? Well, we're still going to do exactly the same thing we did before. So for the foci, we're going to add and subtract the square root of 5, but we're going to add and subtract it from the actual center along the vertical major axis. So we're going to change our y again. So we're going to have 1, comma, negative 2, minus the square root of 5. That's all you've got to do. You do not have to come up with a decimal. And then 1 comma negative 2 plus the square root of 5. Now, once again, remember, I'm changing the y value because that's where my vertical major axis, my major axis is vertical in this case. All right, so anyway, estimate about what that is. Well, you know that the square root of 5 is going to be roughly 2.1 because the square root of 4 is 2. And just imagine what it would be. Negative 2 minus 2.1 is going to be negative 4.1. So roughly about right there. And then if I add 2.1, I'm going to get a little bit over 1. So if I have negative 2 plus 2.1, I have a positive 0.1. So there's where my focus for that side is going to be. So there are your foci, and there are the foci listed out. All right, now here's another one. I want you guys to try it. So pause the video, graph it on your own, and then come back and I'll show you the solution and you can check to see whether or not you got the correct answer or not. That's the whole thing, is you want to be able to replicate this work. Not by copying it, but being able to do it because you know what you're doing. So try to graph this and find the foci, graph those as well, and then come back. I'm going to pause the video here, and then all of a sudden the solution is going to occur. I'm not actually going to work it out for you. I want you guys to try it and then just check your work. Okay, so here's the solution for it. The center, of course, is at negative 1, positive 2. Change those signs when you pull it out. And then you've got an a of 3, the square root of 9, a b of 2, the square root of 4, and it's a horizontal major axis because my larger of the two squared numbers is under the x. All right, so that gives me vertices that are going to change my x value. So I'm going to add 3 and subtract 3 from negative 1. So negative 1 plus 3 gives me 2. Negative 1 minus 3 gives me negative 4. So I get negative 4, 2, 2, 2. And that's this point right here and this point right here. And then minor vertices, I'm going to add and subtract my b value from my y value. So 2 plus 2 gives me the 4. 2 minus 2 gives me the 0, with giving me negative 1, 4, and negative 1, 0. This point right here, this point right here, my minor vertices. All right, and of course, using those points, I can draw my parabola, or sorry, not my parabola, but my ellipse. And yeah, if you're looking at this graph and saying, hey, that doesn't look like your normal drawings, well, you would be right, because I cheated like crap on that one. And I used the shape tool to actually graph that. So I did cheat, but that is a nice pretty ellipse there, isn't it? And then to find the foci, you're going to move along the horizontal major axis. In other words, your x value is going to change, and you're going to add your c and subtract your c plus 5, square root of 5, and minus the square root of 5. So you get negative 1 plus the square root of 5. Remembering that the square root of 5, just like we found last time, is roughly around 2.1, just an estimate. So negative 1 plus 2.1 gives me 1.1. That gives me this focus right here. And negative 1 minus the square root of 5, comma 2. And negative 1 minus the square root of 5, negative 1 minus 2.1 gives me negative 3.1. Now, guys, when you write your foci points, I want these. I don't want the decimals. I want you to write those things out just like it is with the addition of the c. Now, guys, if c had turned out to be 3, let's say it turned out to be an even number, not a square root, you can go ahead and simplify that. I'm fine with that. But if it's a square root, I want you to write it like that, as negative 1 plus the square root of 5, comma 2. That's one focus. And negative 1 minus the square root of 5, comma 2. That's the other focus. But I want you to write those points out like that, not as decimals. All right, now a semi-elliptical archway over a one-way road has a height of 10 feet and a width of 40 feet. See this figure right here. Your truck has a width of 10 feet and a height of 9 feet. Will your truck clear the opening of the archway? So what you're looking for here is you're looking for an equation that's going to define this height at any point along the way. So we're going to have to define this. This is actually half of an ellipse, this arch is. So we're going to be able to define that and see exactly what's happening. Okay, so we're going to have to look at this a little weirdly, but I want you to see what's actually going on here. So let me draw something just a little different here. I'm going to draw an ellipse, or try to. Go a little further and I'm going to have to move it. All right, and this thing is kind of, the picture is a little off. It's actually at an angle, so it's not going to fit exactly, but that's the idea. And what we have here is we have the roadway going right across here. Let me actually draw this over here and it may make a little more sense. All right, so here's my roadway, here's my complete ellipse. The top part is the only thing that is above ground. And of course we've got our line, which is the roadway, going right through here. Now we know that this is 10 feet tall, 10 feet high in this direction. So that is your B. And we know that it's 40 feet in this direction, but that's the entire length of that major axis. So your A is 20. So what you have here is this equation. The equation for this ellipse can be defined by x squared over 20 squared, which is 400, plus y squared over 10 squared, which is 100, equals 1. That's the equation that defines this ellipse right here. Now, we're not worried about this bottom part. The bottom part technically does not exist. And here's the neat thing about an equation like this. When we go to solve for this, we're going to end up having to take the square. If we solve for y, we're going to end up having to take the square root of y. Let's go ahead and solve this. So we're solving it for y, so we're going to move that x squared over 400 over. So y squared over 100 equals 1 minus x squared over 400. Now we're going to multiply both sides by 100 to get rid of the 100 on the bottom here. So we're going to get y squared is equal to 100 times 1 gives you 100. And then 100x squared over 400, the 100 and the 400 will reduce each other to get x squared over 4. All right, now at that point, what do we know? Well, we need to solve for y, not y squared. So we're going to take the square root of both sides. So if we look at all possible solutions here, we've got to remember that anytime we take a square root, we're taking a plus or minus. And that would be plus or minus the square root of 100 minus x squared over 4. Now I want to show you something here. This is the roadway, yes? Well, think about it also as the x-axis. That means that these are the positive y values and these are the negative y values. So when you do the plus or minus, if we were to ignore the minus part for us to represent ourselves up here with this, that's only doing this part of the ellipse. The bottom part would not actually be there with this equation. This is only graphing the top part. And you could even graph this in a graphing calculator and do y equals the square root of 100 minus x squared over 4, and it's only going to graph the top part. It's not graphing the bottom part of the ellipse. And that's fine with us because we don't need the bottom part anyway. We don't care about this part down here. We're only worried about that right there. So if this is defining the y value, the top part here, then how do we find if our truck is going to go through there or not? Well, here's how we do that. Let's go over here and look. Let me go ahead and get rid of this ellipse so the picture's a little better. Let's go ahead and get that out of the way and get this out of the way. And let's zoom in just a touch. Now, our truck is 10 feet wide. So from here to there is 10 feet. And it has a height of 9 feet. So we want to know at this edge and at that edge, will 9 feet go underneath this curve here? Well, that means we need to figure out where exactly in that curve we are. Well, let's say we split this, go right down the middle of this where it's at its highest point. That means that we're going to have how far to get to this edge? Well, it's going to be 5 feet. So what we're looking at now with our graph, remember we've got this highest part right here. And that is our y-axis. So if we talk about how far in this direction we're going to go, if we were to drive this truck right down the middle, if we can find out what the height is over here at 5 feet, and if it fits underneath our curve here, then we know that our truck is going to fit through. So that's all we've got to do. We want to find y when x equals 5. Now we've got an equation for this that we've already found, and it's right down here. We just can't see it right now because I'm not down there far enough. There is my y value. All right, so let's find it when x equals 5. So y equals 100 minus 5 squared over 4, and we're taking the square root of that. All right, so 5 squared over 4, 5 squared is 25, 25 over 4 is going to be roughly 6. We end up with, let me go ahead and do that, 100 minus parentheses 25 divided by 4, and we end up with 93.75 that we're taking the square root of. 93.75. All right, and then we find out what that is, and that is going to be 9.68. And that should be an approximate value. All right, so 9.68 feet. So that means that over here at 5 feet, I'm at this height is 9.68 feet, and my truck is only 9 feet. So it's actually going to fit, but it's going to have 0.68 feet of clearance. That's it. And I've already calculated that out, and it was about 8 inches. So it's going to have about 8 inches of clearance, and that's if you drive exactly straight down the center of this ellipse. If you go too far to one side or the other, the top of the truck's going to scrape, and it's going to be messy and nasty, and you're going to get stuck in the opening. So that's how you go about it. And guys, don't freak out over this. This is not a question that I'm going to expect you to just come up with off the top, the solution to off the top of your head. I would help you through it a little bit and things like that. But you do need to realize that the algebraic expression of that ellipse is just an equation. Everything that you've done from day one in Algebra 1, you can do with that equation. You can rearrange it anytime, any way you need to, and all that. Now, why does this fact that I've solved for y, why is it important? Well, what measures y? Up and down. And that's what I'm measuring here is the height. So that is the y value. Why did I want to find the y value at 5? Because that's what I'm worried about. The y value here at 5, let me change colors. The y value right here at 5, at the edge of the truck, is what I'm looking for. Is it short enough, or is the ellipse tall enough to allow this truck to go through it there? But see, the 5 foot, that's when the ellipse is going to be at its lowest point. It's at its highest point here in the center and splits the difference down the middle. So 5 feet over, the ellipse is going to drop to its lowest point that the truck is going to see. And we calculated it to be 9.68 feet. Well, the truck is only 9 feet. That's why it passes through. So be able to look at these problems and break them down, rearrange algebraic expressions, and get information that you actually need from them. All right, that's all the notes for 9.1. I will see you guys next week, I guess.